All right, so we're going to take a look at rectangles in this video. So we're going to find measures involving the diagonals of rectangles. So there's a couple of things that we do need to remember or learn about rectangles in particular. So think, what do we already know about rectangles, which are a special type of parallelogram, by the way. So here's a rectangle. We already know that opposite sides are congruent and parallel because it's a parallelogram, right? So we already know those qualities exist. We also know that opposite sides are congruent, but specifically that they're 90-degree angles because it's a rectangle. So a rectangle or square have 90-degree angles. Something special about a rectangle is that the diagonals bisect each other, but they're also congruent to each other. So in normal parallelograms, they're not congruent to each other, but in a rectangle or square, they are actually congruent diagonals. Okay, so these are all the pieces of a rectangle, and we're going to use these to help us find some missing lengths here. So we're going to go through, and first we're going to label our diagram. Little thought bubble. This is a midpoint for both diagonals, right? So remember to label your given information. It's much easier if you draw this and you label it instead of trying to remember everything. So AE is 4x plus 5. BE is 6x minus 7. Angle AED, so I marked this in pink, is 118 degrees. And they want us to find AC, which is this whole diagonal going across here. And they want us to find ECB, which is this bottom kind of, not fully right angle, but part of the bottom right angle here. All right, so we're going to go through and we're going to think about what do we know. So the first thing, we're asked to find AC and ECB. So make sure you understand, what are you being asked to find? So what do we know about AC? Well, I know that half of it, remember this is a midpoint for a rectangle or for a parallelogram in general, that's not just a rectangle. I know that half of it is 4x plus 5. So we need to know what x is, because if I know half of it, then I could just double it, right? That would give me the whole thing, but I need to know what x is in order to double it. Well, we can use the two diagonals, because remember, these two pieces, just like this one up here, they equal each other. This is a midpoint for both, and special for a rectangle, they're equal to each other. So 4x plus 5 equals 6x minus 7. So now I'm going to go through, I'm going to solve. I'm going to subtract 4x from both sides, and you can choose. You didn't have to start with 4x. That's just what I chose to start with. You can choose any number when you're in this situation to start with. So 4x minus 4x cancels. The 5 drops down. 6x minus 4x is 2x, and the negative 7 drops down. All right, so now I want to start solving for x. You know, now that I've made my choice on the 4x, now I kind of don't have a choice on what to do next. I need to move this 7 by adding to both sides so that I can get x by itself. The 7's cancel. 5 plus 7 is 12, and the 2x drops down. So the last step to get x by itself is to divide by 2. 12 divided by 2 is 6. So x is 6. Now I'm not done yet, because remember, that was just what x was. Now I need to go back and plug it in so that I can figure out what AE is, and then double it. Okay, so AE equals 4x plus 5. So 4 times 6, because we just found that x is 6. So 4 times 6 plus 5 is 24 plus 5, which is 29. So now AE is 29. Remember, that's half of AC. That's just the top half. I want the whole thing. So I want 29 and 29. So I'm going to go AE times 2, which is 29 times 2. So that's 58. So now we found AC. Now we get to go and find angle ECB. All right, so we have to go through and we have to find angle ECB. Because we found AC, now we have to find the angle. So we're going to have to do a couple of things in order to do that, because they only give us one angle measure. So first, vertical angles are congruent. So angle BEC is going to be 118 degrees. I can kind of cross over here and go 118 degrees. So I've at least brought the 118 degrees over into this area of the angle that I want to find. So the other thing that I can do is that angle EBC, so this top angle, and angle ECB, the one I'm actually looking for, this bottom one, are going to be congruent. And I know that because of the isosceles triangle theorem. So if two sides are congruent, then the angles opposite those sides are also congruent. So I know these two angles are congruent. So now I've set myself up so I can use the triangle angle sum theorem. Even though I don't know the two angles here, I know that they're equal to each other. So, and the triangle angle sum theorem says that all three angles of a triangle have to add up to 180 degrees. So if I say angle 118 plus this question mark and this question mark, right? I don't know what they are, but I know they're both the same. They're whatever they are, and I'm just using question marks to be funny here. So question mark plus question mark equals 180 degrees. So now I have 118 plus 2 question mark equals 118 degrees, or 180 degrees. I'm going to subtract 118 from each side, and I get 118 minus 118 cancels, and I get 2 question mark equals 62 degrees. Well, I don't want to know what 2 of them are. I just want to know what one of them is. I just want to know this one down here. They're both exactly the same. So I'm going to divide by 2 so that I know what just one of my question angles are. It's 31 degrees. So angle ECB is equal to 31 degrees. All right, so that was using diagonals of a rectangle to find lengths and angle measures. I hope that helped, and I'll see you in the next video.